Alright, Assalamualaikum and good afternoon. So today we will discuss on dynamic and process control for simulation for distillation column. Okay. So first thing first, before we start our simulating, we know that we have to gain the transfer function, and to do that, we have to first step of the transfer function is called modeling. So in the modeling, we have condenser or reflux drum, top tray, next to top tray, and top tray, feed tray, first tray, and reboiler. What does this mean? Because I will show here. Since distillation column consists of many tray, we have the feed tray, which is where the reactant or the component is being flow in. This is feed tray, and then we have the top tray here, and we have reboiler here. Reboiler, and we have this is condenser, and this is reboiler. Okay, so below we have feed tray, we have end tray, which is it is in the distillation column called end tray. So for example, if we want to measure tray number 7, so the end tray will be 7. Okay, we have first tray here and the top tray here. Okay, so next next step, once we have obtained the modeling based on its overall mass balance or energy balance, so we have to develop a transfer function. So in this section, we took top tray, condenser, first tray, and reboiler. I'm sorry for the typo. So because this is the easiest equation that we have obtained from the modeling. Right. So next, on servo control system. So servo control system regulates the process to follow the changes in set point for no load change. This system does not have load change, and its response to change in set point. It means that once we have obtained the transfer function, we develop the simulating. So this will be our process. And then this is our step input. And this is our controller. So what we have here is our measurement of error, which is consists of square error, ISE, absolute error, IAE, and time weight absolute error, which is ITAE. The same goes for the bottom here. So once we have developed all the block diagram in the Simulink in MATLAB, we can run the process. So I will show here. So this is the graph that we have obtained from previous Simulink, which is consists of P controller, PI controller, PD controller, and PID controller. What does it mean of P controller, PI controller? P controller is mean that we only input the value of P controller, and while with mode of PI, PD, and PID controller. The same goes for PI controller. We input the value of P and I, and mode of D controller. For PID controller, we include all the parameters proportional, integral, and derivative value. So as we can see here, P controller did a good job in showing the oscillation and the overshoot, but it quite missed the it missed this spot, which is the set point. So our set point is about smaller than 1, because the composition, the X composition that flow out from the system, which is distillation column, must be less than 1. So that's why our set point is less than 1, maybe 0.95, something like that. Okay, for the PI controller shows this graph, and PD controller this graph, and as we can see, PID controller gives the best result, because it's based on overshoot, based on number of oscillation, and the no offset. Okay, the same goes for the XD and this is graph is for XB, which is composition in the bottom. Okay. Next, we will proceed to server control if we input multiple set point. This is quite complicated compared to single input control system, because we added these variables here, so that we will obtain various of graph. Okay, so in this section, server control system regulates the I'm sorry, this is as the previous slide. So for the once, as we know that we have multiple set point, so for multiple set point we introduce step point 1, 2 and 3 and 4. Step time here is 1.5, sorry, it's 15 seconds, 20 seconds, 25 seconds and 30 seconds. Final value will be 0.25, 0.4, 0.5 and 0.9448. Okay. Next. Okay, this is graph obtained based on the multiple set point that we have introduced in the last chapter. Okay, so as we can see here, P it should be the same as the single set point, but in fact we have multiple stage here. So as you can see, P give a good result, while PI and PD give some error here, while PID as the same before give the best result out there, because based on observation, response time and no offset. Okay, as you can see here, because we introduced four set point, so we have 4 stage here, 4 step, 1, 2, 3 and 4 here. Okay, so that's all for the multiple set point. We proceed to method of tuning. So why we required tuning in this Simulink? So first I will explain what is PID tuning. PID tuning is the process of finding the values of proportional, integral, derivative gains of PID controller to achieve desired performance and meet desired requirement. It means that we have to obtain the best performance based on that criteria, such as overshoot, offset, response time, first time peak and so on. Okay, so tuning is very important. Next, okay, as we know, we learned that in class that method of tuning consists of two, which is Ziegler-Nichols method, Kohn-Kuhn method. This other tuning, but this is two main tuning that has been used in many industries. Okay. Okay, first we will go on Ziegler-Nichols method. So for the Ziegler-Nichols method, sorry, this is our broad diagram, which is we introduce the gain here. This is P, I and D. For, as you know, in Ziegler-Nichols method, we turn off I and D value, while we on only P controller value. So we add the P controller value until the oscillation reach at certain sustained period. It means that for example, we got KC value is 1, which is because we only add the proportional. So our graph will be like here. This is set point. Sorry, this is set point. Sorry. You can ignore this part. For example, we got oscillation. So once it give a consistent or constant oscillation, that Kc value will be our Ku value. So in this problem, we got the Kc value is 1000. So it means that once it reach 1000, the oscillation curve is consistent and sustained periodic oscillation. It means that the value is the same right here. It means the period. I will show you. Next. Okay. This is as I mentioned before. When the Kc value, sorry, this is too large. Kc value is 1000. It gives a consistent value. It means that the range from here is the same of range here, and the height also is the same for all certain axis point. Okay, so when we obtain Ku is 1000, we have to find Kc, tau I, also tau D. Okay, based on the formula. So we will obtain all this value based on formula. You can check the formula later. So we have once we have obtained all the value here, we insert the value of Kc. For example, if we want to make it as P controller, we only put the Kc value as 400 into the system, into this system. So for example, is Kc back then is 500, so we add 500, and this is a 0 and 0. So for the case, the same goes for the PI controller, which is Kc is 450, and we add 450 here, and sorry, and 5.245. At the I controller value. Okay, I'm sorry. Okay. What is this? Okay, next on. This is the value that we obtain from the Ziegler-Nichols method. Okay, as we can see, when we input only P controller, which is 500, the graph that we have obtained is right here, while the PI controller, which we obtain P and I variables, we obtain value here, and for PID, the controller is like this, which is no offset. Okay, so this is a good result, because based on what we have learned, PID gives the best result out there. So PID controller gives the best result based on tuning, on Ziegler-Nichols method. So next tuning method is called Cohen-Kuhn method. So for the Cohen-Kuhn method, first we run the process as usual, and then we introduce step change. And make the process open loop. So after the controller, we cut the Simulink to make it as open loop. So the graph at the left side here is obtained. So for the graph, we draw the tangent line based on the inflection, and we gain the S, which is the slope value, and T based on the formula Bu over S. Okay, this is our Bu, which is 0. Okay. I'm sorry, Bu is 0, Bu is negative 400. Okay, once we have obtained the all the parameters given, we can obtain, like the Ziegler-Nichols method, we can obtain the Kc, tau I, and tau D based on the formula on Cohen-Kuhn method. You can refer the table. Okay, after we got the each of the controller value, we insert back to our our simulink here. So this is will be our P value, this is I value, and this is D value. Okay, so next, oh my god. Okay, so we obtain the graph as shown here. So that's all for me, and I can say that in conclusion, I can say that Ziegler-Nichols method gives the best result compared to Kohn-Kuhn method in this problem, because and the best controller is PID because it gives the best performance, the best response curve based on the criteria performance. That's all for me. I'm Muhammad Irfan Shazmi bin Jamaluddin. A176956 is my matrix number, and goodbye.